Okay folks, a little addendum here, something to add in the form of secondary landforms that you might get from volcanic and from seismic activity. We're going to look at these because it is a good thing to get in. It just shows a bit more development of your ideas. And these are distinctive landforms. There are others, but I'm just going to go for these three because I'd rather you focus on the main content. First off, a volcanic secondary landform. This is a lahar. This is where you've got an ash build-up from, say, a composite cone or a cinder cone volcano. There's an explosion, ash lands, and then it rains. The rains mix with the ash and it forms mud flows. Now these mud flows will create a landform because they are basically a channel of mud, much like a river, and they will coat things in mud. They will create new channels and new banks. So they are a landform. You get it particularly in the Philippines or anywhere where you're likely to get rains from, say, tropical storms on top of a volcano that's got a particularly andesitic or rhyolitic magma, much like in the Philippines, where it's a convergent boundary. So lahars would be a classic volcanic secondary hazard. Seismic activity, it's got to be the tsunami. Tsunami, of course, triggered by either an earthquake or a volcano, but generally an earthquake, sends a pulse outwards. And this is part of the P wave, actually, linking back to the seismic video. This is the P wave sending a pulse through the water. And water moves, the pulses move slower through water than they do through land. So the pulse wave moves through the land, which gives people a little bit of warning that it's coming. Not a huge amount though. Most of the warning comes from buoys in the ocean that pick it up. It moves incredibly fast, and what happens is, because it's a pulse, it moves the water as a block, which means you don't pick it up, you don't notice it until the land starts to get shallower. At the coast. That's where the coastline should be. But what's happened is the block of water has raced up and it's picked up and it creates this wall of water from the pulse wave. So this is the one instance where a pulse wave creates a lot of damage compared to the S wave. Because the S wave just doesn't really travel through water. Tsunamis create a huge amount of landforms in that they destroy everything in their path, including things like forests, all kinds of natural landscapes, but also human landscapes. So they do have land forming potential. Finally, both can cause landslides, volcanoes and earthquakes. Shaking, the movement, the tremors can cause material, particularly if it's waterlogged, to be displaced. Classic example is Haiti. Deforestation didn't help, but it was the earthquake following saturation of the soil that led to the land sliding down. The landform here means that the whole hillside has moved. It's basically a new hillside, and everything beneath gets buried under the land. So these are secondary landforms, worth building in to create the full context of the landscape if you can. So final video coming up is going to be how you can work this into your report.